At the moment of detonation, physics as we know it ceases to exist. This is the anatomy of a nuclear explosion. In the first billionths of a second, a massive burst of X-rays is released, heating the surrounding air into a plasma. Then comes the flash. A burst of visible light so intense it is brighter than 1,000 suns. Anyone within several kilometers looking directly at this light will suffer immediate and permanent retinal burns. Within 3 seconds, the fireball forms, a sphere of superheated gas and plasma reaching millions of degrees. At its core, anything in its path, concrete, steel, and life, is instantly vaporized into its constituent elements. As the fireball expands, it pushes against the surrounding atmosphere, creating a high-pressure shockwave. Moving faster than the speed of sound, this blast wave levels buildings and turns every loose object into a deadly projectile. Simultaneously, a thermal pulse of infrared radiation radiates outward, carrying nearly 35% of the total energy. This heat travels at the speed of light, causing third-degree burns and igniting fires tens of kilometers away. After the blast wave passes, a vacuum is created. Air rushes back toward the center at hurricane speeds. These inrushing winds fan the thousands of secondary fires started by the thermal pulse, creating a firestorm. Within minutes, the classic mushroom cloud begins its ascent. The fireball, now buoyant, rises like a hot air balloon. It pulls millions of tons of pulverized earth and debris upward into the column, where it becomes highly radioactive. The cloud can reach the stratosphere, where the radioactive particles are carried by high-altitude winds. As the superheated air cools, water vapor condenses around the radioactive dust, forming dark, heavy clouds. Within 30 minutes, the black rain may begin. This oily, radioactive rain is a lethal primary source of contamination. Then comes the fallout. Larger particles of debris, coated in radioactive isotopes, begin to fall back to Earth. This fallout is the most significant radiation danger, creating a plume that can extend for hundreds of kilometers. It is a silent, invisible threat, settling on every surface and contaminating the water and food supply. Radioactivity is most intense in the first hours, decaying rapidly, but leaving a lasting legacy of environmental damage. For those outside the immediate blast zone, the first 10 minutes are a critical window for finding adequate shelter. Sheltering underground or in the center of a large building can reduce radiation exposure by as much as 90%. Removing outer clothing and washing skin can prevent the further spread of radioactive particles. Communication is often the next casualty. The electromagnetic pulse, or EMP, fries electronics and cripples the power grid. In an instant, the modern world is disconnected, leaving survivors isolated in a landscape they no longer recognize. Understanding these stages is not an exercise in fear, but a study of the most powerful forces humans have ever unleashed. The first 10 minutes after a blast define the boundary between the world that was and the world that remains. The question remains, how do we ensure these forces are never used again? Join us next time as we dive deeper into the archives. This is Weirdly Explained.